Welcome to my first ever HSC Math Extension 2 question video, and I'll give you a second to pause the video and look at the question. Okay, so the first question is show this. It's a one marker. It should be really easy. You just set the ratio to be x, which is what we usually do, and we can get rid of the ratio form, and we can plug in the value and get rid of the common factor, and then you can reach the equality. So that's not what I'm trying to say in this video. The really good question is this 3 marker. So hence, if cosine x plus cosine y plus cosine z over cos x plus y plus z equals to sin x plus sin y plus sin z over sin x plus y plus z equals to t, you're asked to show that t equals to this. Now we must know that this, if we want this to be true, x, y, z can't be any real number. It's restricted. That's why they must follow this. So it's not the x, y, z can be any value. They must be in a relationship, and the relationship is that the ratio of these two equals to this. So let's first look at this. It's a extension 2 question. So what can we use for trig? Can use the trig identity, of course, but for this one we have a more elegant way, which is to use the complex number and Euler's identity, because look at this, it's a lot of brackets, and if you want to expand them, we have like product to sum and sum to product, or we can expand this, but it would make it extremely complicated. So I think we should try to use the Euler's identity first. So how we're going to construct it is the gist of this question. Now if we want Euler's identity, we must have a cosine x plus I sine x, right? It's like this. So we multiply by I on both sides, up and down, for this one, because we want the form of Euler's identity. So this is true, then we can apply the result from the question 1 and add them up together. We get this very elegant form. Now it's just one step away to here. When I reached here, initially I was confused, because t is absolutely real, right? Why on earth did it turn to this complex form? But now I know that if t is real and the logic is all correct here, then there's only one explanation. This thing's imaginary part is 0. So we can say that the imaginary part is 0, and the question could have let you show that the imaginary part is 0. So sine, if we basically say this is sine, they plus together would be 0. You can try this, because it's another thing the question could have asked you. Now they didn't ask you this, so you can say that the imaginary part is 0. So t equals to cosine, and you use the very easy trig identity, you get this. So this question is very good, because I haven't seen a question like this. It's how you can, in an extension 2 question, approach trig identities using complex numbers and using Euler's identity. It isn't hard if you know how to do it. If you realize that you need to use the identity, I think you already get most of it, because I think it's easy. Once you get this step, then you use the result from the last step, you get this, and then you get this. It should be easy for a proficient extension 2 student, but to realize that you can actually do this, it's tricky. This step is tricky, and from this step to this step, I think it's tricky as well, because if all the you need to have the confidence that if all the logic is right, then if there should be no contradiction in your result. So this is a real number, so the imaginary part is 0. So these are the two hard points in this question, and it's a generally very new and a very well written question. So I think we can learn a lot from it. If we link that to syllabus dot point, it's a complex number question. But the hard thing about extension 2 is you don't really know what it is assessing, because it's so interconnected and they can assess one concept from a lot of perspectives. So that's all.